Hello students, today in this video we are going to study about viscosity. You already know that viscosity is basically the friction between different layers of the liquid. If you assume to be one layer like this, and if there is a tangential force is acting and it will move with the velocity v, and the next layer will move with a little lesser speed. Why? Because there is suppose it will travel with the velocity v dash, where v dash is less than v. Why? Because this layer and this layer, just like we have solid friction between two bodies moving, there is a frictional force acting in the opposite direction, which is called viscosity or viscous drag. Okay, now you have the next layer, let us say, and this is moving with a velocity v double dash, let us say. You know that v double dash will be less than v dash, which is less than v. So as the layer speed goes on decreasing, at the bottom the layer which is v have the velocity equal to 0. So there is a tangential force which is the external force, and the other force which is acting in opposite direction, because we assume the liquid to be made up of layers, and the friction between the force between the layers which is acting in the tangential direction, that is called viscosity. Now today also we studied about how to derive an equation for viscosity, and what are the factors it depends on, that also we did in the previous video. That I can also called Newton's law of viscous drag, where the force, tangential force, is directly proportional to area of the layers in contact, and the same F is proportional to rate of, not rate I said, the change of velocity with respect to the distance between them, perpendicular distance between them, which we called it as velocity gradient. And when we combined these two, we said a dv by dx, and we brought a constant eta, where eta is called coefficient of viscosity, and a into dv by dx, and there is a negative sign because the viscous drag is opposite to the tangential force. It is against each other, it is in the opposite direction. So today our discussion is going to be Stokes Law. Stokes Law of viscosity. It's a very interesting derivation which we are going to do today. Okay, let us see how we take it forward. Okay. For example, I have a cylinder with me, right? I have a measuring cylinder here. Okay, and I am going to take a liquid in this. I am going to take a highly viscous liquid. What is a highly viscous liquid in the cylinder I am going to take? I am going to take glycerine, or more easily we can take castor oil. Castor oil. It is very highly viscous fluid. I fill this till here with the castor oil. Okay. Now, this is the cylinder you have. Okay. This is the cylinder you have. This is 1000 ml I have taken. The volume does not matter. For this experiment, just I have taken till here. You see, measurement is 250 ml until here it is, okay, it is given 250 ml, but I am taking liquid till here. Now what I do, I am going to take a small ball bearing. A small ball, you signed it in the cycle between and all, you know, small ball we will take it. And this ball is basically made up of steel. Okay, it is made up of steel, iron, steel. And the liquid castor oil is something different. Okay, liquid. Now I am going to drop this in this liquid. I drop in this liquid, it falls down. Okay, it is falling down and passing through, it is going through the liquid. Now what will happen? When it passes through, goes through the liquid, what will happen? The liquid layers will be disturbed. Now the layers are here, right? The layers are going to be disturbed. Where it touches the body, where it is contact, the iron ball or steel ball in contact with the layer, that layer is disturbed the most. Okay, it is moving with a velocity v, and that is disturbed the most, and the layer which is below is not so disturbed till. So this is disturbed, and next this layer will be lightly disturbed. So what will happen? Friction, internal friction, the liquid friction will come into play. What do you mean by that liquid friction? It is nothing but viscosity, viscous drag, and viscous drag will act, and the body will, now as it comes down and down, gravitational force is increasing. It's going to, gravitational force is going to pull now, right? The velocity is going to increase. So the velocity goes on increasing. The velocity goes on increasing, and equally velocity increases, the viscous force also will increase. Viscous force is acting in the upward direction. The viscous force is acting in the upward direction, and in the downward direction the body is coming down. That is because weight of the body mg is acting in the downward direction, and it is having a velocity. Now what will happen? What are the forces acting downward and what are the forces acting upward? We have to think of that. Downward, weight of the body is acting. Downward, the weight of the body is acting. Now what is acting upward? One is the viscous force, the viscous drag which is disturbed due to the internal friction is acting in upward direction. Number two, we also studied in Archimedes' principle, up thrust will be acting. The up thrust is acting in the upward direction. So, two forces are acting upward direction. What are they? The upward forces, I will write here, upward forces. They are the viscous drag plus the upthrust. These two are acting in upward direction. But what is acting in the downward direction? The weight of the body, the weight of the solid, that is W, is acting in downward direction. But which is greater? W is greater. That is why the body is coming down, 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 down. The upthrust is at certain particular point. At certain particular point, the downward force, the upward force will become equal. The downward force and the upward force will become equal, and at that time there is no acceleration. Listen, the downward force and the upward force, downward force is weight of the body, upward force is the viscous drag or viscous force, and upthrust. These two are acting. When they both become equal, balanced, that time no external force is acting. No force external. Force external is not acting. When force is not acting, according to Newton's second law, F is equal to ma, there is no acceleration. If there is no acceleration, the velocity is constant, and the velocity is constant, and that point, let us say at this point it reaches that, from there it will fall with a constant velocity, and that velocity is called terminal velocity. That velocity is called terminal velocity, right? The terminal velocity, it will remain constant. You can do this experiment in a very simple way. Take even you have Stokes Law apparatus, which will have a big like golden tube light. You know, it will have a glass tube, and up and down, and you fill it with around 2 to 3 liters of castor oil. But I do the same experiment, which I will try to shoot sometime. I just take an ordinary one, and I put rubber bands in 1 point, 2 point, and 3 point. Let us say at some distances, I put rubber band, color rubber bands, and I take a small ball rest or ball bearing and I drop it in the castor oil, just in 1 liter oil. Then I study how much time it takes to travel this distance and how much time it travels same distance. From the velocity is equal to distance upon time. Using this, we will be able to calculate the terminal velocity. When the velocity becomes constant, at which point you can put more rubber bands to determine this at equal distances. We can calculate at which point the velocity has turned constant, and that is the point where the terminal velocity has reached. Now in this section, I am going to do first term. I am going to derive the Stokes law. F is equal to. What is this Stokes law? Basically, it is given by the equation. So please understand all these things. I will be shooting another video to continue with this. An equation I will get for viscosity, coefficient of viscosity, and in this we are going to study only about Stokes law. Stokes law, that itself will take some time for us to complete it. Okay. So what is Stokes law? 6 pi eta RV. This is called Stokes law. Dear students, Stokes law is about viscous drag or viscous force, and what it says, F is equal to 6 pi is a constant, eta is coefficient of viscosity which differs from liquid to liquid. Water, vegetable oil or castor oil, glycerine, it is going to change. And R, radius of the ball which is dropped there, right? Whatever material it can be, glass ball, glass bead, it can be steel ball, right? And V is basically terminal velocity or just a velocity at this point we will say. Okay, fine. Let me just clear the wire. Yes. Okay. How can we derive this? We are going to use dimensional method. Dimensional method. That is the chapter 2 is about dimensional method, and I am going to derive this relationship using dimensional method. Now, first we will take what is the physical quantity. Okay. First physical quantity is force and the symbol is F. And next physical quantity is coefficient of viscosity. Viscosity. Okay. That is eta. And third one is radius of the body which is falling down, R. And next is velocity. Velocity. That is V. This is actually terminal velocity. Okay. So just velocity is velocity. So nothing to worry about it. Whether it is initial velocity, final velocity, terminal velocity, critical velocity, velocity is velocity. Right. And dimensional formula. We will write the dimensional formula. Force mL T power minus 2. Coefficient of viscosity, I think in last class we derived it. M L power minus 1 T power minus 1. Radius, length L. Velocity L T power minus 1. Right? And I got this table with me. First I have made the table. Okay? After this, we are going to make a dimensional equation. We say F is proportional to what factor? 6 pi is a constant. We are not going to touch this, right? Eta power A times and R power B times and V power C times. Okay? This is how we form a equation. Fine. Now F, let us substitute the values. Dimensional formula M L T power minus 2. Put it in a square bracket. Is proportional to eta M L power minus 1 T power minus 1 power A times, and then radius L power b times. Fine. And velocity L t power minus 1 power c. Right? Let us expand it. M power 1, L power 1, t power minus 2. Okay? This is proportional to. Still I am not bringing a constant, don't worry. Right? M power a, L power minus a, t power minus a. Stop it. L power b. Stop. L power c, t power minus c. Over. Now bring a equal to. Yeah, you can bring an equal to. Right. So let me skip itself. Okay, let me take one more line. M power 1, L power 1, t power minus 2 is equal to a constant k. Circle it so you don't get confused with something. Now bring the similar terms together. M power a. Next L is here. L power minus a 1 over plus b and plus c over. Next t power. What is the t power? Here 1 is there, minus a and minus c. Done. So we have taken all the terms together. Now comparing all the powers, comparing the powers of M, L and T. We are going to compare the powers. Now let me erase this part of the board. Okay, just see what I am doing. Fine. Eta. Now let me compare here A and here it is 1. A is equal to 1. We got an answer. Already we got one answer. Next, this power L is minus A plus B plus C is equal to this one is equal to 1. Okay, A is 1, minus 1 plus B plus C is equal to 1. B plus C is equal to minus 1 comes this side, plus 1, 2. So I got another equation, B plus C is equal to 2. Third one, I got here minus A minus C is equal to, again I got minus 2. A is again 1, minus 1 minus C is equal to minus 2. Minus C is equal to minus 2 plus 1. Minus 1 comes there. So minus C is equal to minus 1, which implies C is equal to 1. I got another value. Let me substitute in this equation, right? B plus 1 is equal to 2, which implies B is equal to 1. So I got all the values A, B and C. What is the formula here? A is 1, B is 1 and C is 1. We got it? So we can say F is proportional to eta RV. Eta RV. We know that there is a disadvantage of dimensional method where you cannot find the constant. Constant can be calculated only by experimental method, and constant K is given to be 6 pi and the formula eta RV. Eta RV, this is the formula which we wanted, and this is the formula, this is called Stokes Law. So what is Stokes Law? Again, this is we started. This is the constant K which is equal to 6 pi, and we derived that equation by using dimensional method, dimensional approach. I hope, dear students, you understand this. We shall do numericals also based on that, and we can continue more on that. In the next video, I will shoot and find a formula for terminal velocity as well as for viscosity. And thank you so much.